In this video, we will learn how to incorporate the enthalpy of reaction into our stoichiometry math. So in previous chapters, we said that if you had a positive delta H of reaction, then you had an endothermic reaction. Endothermic means that you absorb heat from the surroundings. Also, if you have a negative delta H of reaction, then you have an exothermic process, and that means that you release heat to the surroundings. What we're learning in this chapter is that this delta H of reaction is proportional to these stoichiometric coefficients. And so for every 1 mole of C3H8, I will release, because this is exothermic, it will release 2,044 kilojoules of heat. Or I could say 4 moles of H2O would be proportional to that same amount of heat. So I can use these stoichiometric coefficients. Any of these stoichiometric coefficients are proportional to this value. Let's do an example problem where we incorporate that into our stoichiometry. In this problem, it reads, if 15 grams of nitrogen monoxide is produced, how many kilojoules was absorbed? And we can see that we have a positive delta H of reaction, and so this is an endothermic process, which makes sense because it says absorbed. And so we're asked to find kilojoules given 15 grams. Now, we are given grams, but these stoichiometric coefficients relate moles. And so I first have to go from grams to moles, and then I can go from moles to kilojoules. How will that look? Well, I'm given my 15 grams of nitrogen monoxide. I will need to cancel out my grams of nitrogen monoxide and get into moles using the molar mass. We use molar mass every time we want to switch between the units of grams and moles. So if I add up the molar masses of each element, I get the mass of the compound, which is 30.006 grams per mole. Next up, I have to use my ratio. This is nitrogen monoxide, I have to cancel out my moles of nitrogen monoxide, and I have to get into kilojoules. So this number here is attached to the moles, and then this number goes in my numerator. So let's type that into our calculator. We have 15 times 1 divided by 30.006 times 181 divided by 2. And that is equal to 45.24 kilojoules. That is a positive value because it is endothermic. And we have 3 significant figures. And so this is 3 sig figs. We will round to 3 significant figures, and that is 45.2 kilojoules. Here's another practice problem. It reads, how many grams of O2 reacted if 1,280 kilojoules is released in the following reaction? Go ahead and pause the video and try to work this out on your own. Okay, you have an answer? All right, let's see how you did. Now this is released is an indication that we have an exothermic reaction. So my Q of reaction is equal to negative 1,280 because it is exothermic. So if I start with my negative 280 kilojoules, and I need to go from kilojoules to moles of O2, and then I will get into grams of O2. So let's map out my units. I need to go from kilojoules to moles of O2, which is here. Then I need to go from moles of O2 to grams of O2. And then this is our molar mass, because again, we are converting between the units of moles and grams. So this number goes down here, and that 2 goes there, and so that made my conversion factor. Next, the molar mass is always out of 1 mole. So the molar mass of O2 is 15.99 times 2, and so that's 31.998. Type this all into my calculator. And I got 92.039 grams. I need 3 significant figures. 1, 2, 3, 92.0 grams. It's important to realize also that mass is always positive. If you ended up with a negative mass value, it's a clue that you missed one of these negative signs. And so go back and check your work and make sure that you have both negative signs. 2 negatives make a positive.